Welcome back. This is Module 3 of the FRC Introduction to Java Programming. We've already covered a little bit of the history of programming and we reviewed object-oriented programming. Remember, in object-oriented programming, we learned the four principles are encapsulation, abstraction, inheritance, and polymorphism. We also learned about some of the relationships that objects can have. Inheritance is the is-a relationship, and the has-a relationship can be covered by either composition or aggregation. We also covered the introduction to the Java language itself, how the language is structured, how we create a class with the package statement and the import statement. We went over the access specifiers, public, private, protected, and package, and we looked at the declaration for a class attribute or a local variable, and we also looked at the declaration of methods. And a method always has a return type, which if it has nothing to return, it's declared as void. So a void method returns nothing. The one exception to that is a constructor. A constructor has no declared return type at all, not even void. And what is a constructor? A constructor is a special class whose job is to initialize the state of an object when it's created. Every class has a constructor. If you don't declare one yourself, the Java compiler will insert one for you and make it public. So just be aware of that. So now we're going to look at program logic. Program logic is how we assemble commands in Java to make things happen. Okay, a Java statement is a complete unit of execution that's delineated with a semicolon. So a Java statement is the building block of all our Java program code. Inside Java methods, you're going to see a series of statements. The statements will be executed one after another in sequence from the top of the method to the bottom of the method. So that's how we get a Java program to do things. We've already seen the use of curly braces to delineate interesting structures in Java. A class declaration is delineated by an open curly brace and a closed curly brace. And within the class declaration, we've seen that methods themselves are delineated with an open curly brace and closed curly brace. Java statements can be grouped into blocks of code delineated by those curly braces. So pretty much anywhere a Java statement is allowed, you can put in a block of code that will be treated as a single statement. So here's an example of one Java statement. This is an if statement, which I've gone over a little bit in the past. I'll go over it again in our next module. It starts with the reserved word if, and then inside parentheses it has one Java expression. I'm going to go over Java expressions in just a moment. After the expression, it has one Java statement, and that Java statement will be conditionally invoked only if the condition evaluates to true. So in this case, my one Java statement is going to invoke a method. How do I know it's a method? I know it's a method because it has a name followed by parentheses. If I have a name followed by parentheses, that's the invocation of a method. If I have a Java name without parentheses, it's treated as a variable or a class attribute. So let's see an example of a Java statement block. I have another if statement. If motor1 can ID does not equal 0, the exclamation point is pronounced not in Java, so that's not equal to 0. We have one Java statement, but in this case our Java statement is a Java block. We delineate the start of the block with an open parentheses, and we delineate the close of the Java block with a closed parentheses. Everything inside this block is treated as one Java statement that's executed from beginning to end. Interestingly, remember going back to the first module, I was talking about the call stack and stack frames, and whenever you invoke a method, we create a new call stack and push it onto the call stack, and that stack frame contains all the local variables in that method. When we create a Java statement block, we're also creating a new scope. So any local variables declared inside this Java block exist only in the scope of this Java block. They do not exist outside the Java block. That can introduce some errors if you're not careful. So pay attention to that. If you declare a variable I in a method as a local variable, and then inside a Java block declare a different variable I, inside the Java block you'll only see the new nested variable I. And when you exit the Java block, you'll see the original local variable for the whole method. So in general, it's not a good idea to use the same variable name in more than one block. So I mentioned with the if statement that the if statement starts with the reserved word if followed by an expression inside parentheses. So what is an expression? A Java expression basically evaluates to a single value. We can use expressions in variable declarations, we can chain them together with operators, and we can use them in method invocations. Multiple expressions can be chained together with operators as long as the data type required by one part of the expression matches the data type of the other part of the expression. So here's an example. In this first example, x times y times -1. If x is an integer and y is an integer and -1 is an integer, they're all compatible types and we can use the multiply operator. Here's another example, is enabled and is autonomous. Both is autonomous and is enabled are Boolean variables, and the double ampersand is a logical and. So we're anding a Boolean and another Boolean. So that will evaluate to true only if both is enabled and is autonomous are equal to true. If either one of them is false or both of them are false, it'll evaluate to false, which is also a Boolean, which is a compatible type. So what are all the operators in Java? Java has a pretty rich set of operators. Operators manipulate values. There's 6 basic kinds of operators. The arithmetic operators, which are used pretty much the same way they are in algebra, assignment operators, unary operators, comparison operators, logical operators, and bitwise operators. I'm not going to go over bitwise operators in this course, but just know that they are there if you need them. Arithmetic operators, they come in addition, subtraction, multiplication, and division. They work pretty much the way you would expect in mathematics. The addition operator takes 2 values, a left value and a right value, and it adds them together. Subtraction works the same way. Multiplication, division, they all take 2 values. The one note is with string objects. String objects are special in Java. They allow the operator plus, but in the case of a string, operator plus is concatenation. So the string book and the string case, if I add them together, I end up with the string bookcase. I don't do mathematical operations with strings. There's one other operator, which is modulus, which is the percent sign. The modulus operator calculates the remainder. So 15 modulus 3 would be 0 because it has a remainder of 0. And 13 modulus 4 would have a value of 1 because 4 times 3 is 12, so there's a remainder of 1 trying to fit it into 13. Assignment operators also take a left value and a right value. Basically, they take whatever is in the right value, which is another Java expression, which is chained together, and stuff it into whatever you put on the left side. So the left side of the assignment operator is always an attribute or a local variable or something like that that can receive a value. The right side can be any Java expression. There's the one simple example, equals. Enough said. There's also plus equals, minus equals, splat equals, slash equals, and modulus equals. Those are shorthands. So plus equals is the same as saying x equals x plus y. X plus y is an expression that does addition, and then the equals is an assignment. So we're evaluating the expression x plus y. The result of evaluating that expression is then assigned to the variable x. So we're overwriting what it used to have when we evaluated this expression with its new value. So that's just a shorthand. I should mention splat is a phrase that I use for asterisk. So when you hear me say splat equals, that's the same as saying asterisk equals or assignment, multiplication assignment. But splat equals sounds better. The unary operators only take a single operand. The previous ones, the assignment and the arithmetic operators, took a left-hand value and a right-hand value. Unary operators only operate on a single value. So what is unary plus? Basically, that says the number that follows is a positive number. You can see an example here where I have a local variable, Avogadro's number, which is then assigned to 6.0221409 times 10 to the positive 23rd. So there's my unary plus operator that's saying the 23 that follows is a positive value. Unary minus is a negative value. So I have a local variable radian, and I am assigning it to negative 57.2958. So it operates on the value that immediately follows it. Plus plus is the increment operator. So it increments a value by 1. And there's two variants of it. There's the pre-increment and the post-increment. Pre-increment has the operator prior to the value. So plus plus I is a pre-increment, and I plus plus is the post-increment value. After the evaluation, they both result in the operand being incremented by 1. The sequence of how the expression is evaluated is slightly different between pre-increment and post-increment, but that's a little beyond this course. Minus minus is the decrement operator, so it decreases a value by 1. And we can see it also has a post-decrement and a pre-decrement, and they work pretty much the same way as the increment. The two versions, the post-decrement and the pre-decrement, are evaluated differently, but the result of the evaluation is the same. The variable is reduced by a value of 1. And I already mentioned exclamation point. That's pronounced not. That's the logical complement operator. So if I put it with a Boolean, I would read this statement, if not found, which is the same as saying if found equals false. So I just said if found equals false. In that case, I'm using the equality operator. The equality operator in Java is a double equal sign. The single equal sign is assignment, and Java will give you errors if you inadvertently use the wrong one in the wrong place. With equality, we also have its logical complement, not equal. So exclamation point equals is read as not equal. So that's an inequality operator. We also have, for numeric values, greater than or equal to, less than, and less than or equal to. Make note that in Java, we have primitive types and object references. Primitive types work as you would expect with algebra. Equality, inequality, greater than or equal to, less than or equal to, all work on the content of the number stored in a numeric type, or the value for a Boolean for equality and inequality. The difference is object references. When you are working with an object reference, the value that it contains is the address in memory where that object was created. Remember, in Java, when I create an object, I'm always creating the object on the heap. And when I create an object, I get back the address of the memory location where that object has been placed on the heap. So if you use equal and not equal comparison operators on an object reference, I'm comparing the address of the object, not the contents of the object. The logical operators I already touched on with the double ampersand. That's the logical AND. It has to evaluate to a true or false value. So here's an example of an if statement. If is enabled and is operator control. Both of those are methods, so I'm going to evaluate those methods. How do I evaluate a method? I invoke the method, and in this case, is operator control returns a Boolean value, and is enabled returns a Boolean value. So if both of these are true, I'm going to execute the next statement that follows, which, because of the Java coding conventions, we know is always going to be a block of code in parentheses, in curly braces. I also because of the Java coding convention, I know that this method returns a Boolean because it starts with the word is. In Java, the convention is we name a method starting with the word is if it returns a Boolean. So that's, again, it makes your code easier to read and easier to understand and easier to pronounce. I would read this line of code as if is enabled and is operator control. That almost sounds like an English sentence. Logical OR is two vertical pipe characters with no spaces between them. So that's true if either operand, the left-hand operand or the right-hand operand, are true. So in this case, A or B would evaluate to true if A is true, or if B is true, or both of them are true. It would only return false if both the left and the right hand are both false. The most commonly used operator in Java is actually the dot operator. Dot is used as the member of operator. So if I pick apart this next statement, we start with the name of the method. We are going to invoke the shoot goal member of the GameMech object, technically the object that the GameMech variable references. And we're going to pass it a parameter. The parameter we're going to pass it is highGoal member of parameters. I can look at this, and by using the Java naming conventions from our coding standards, I can immediately tell highGoal is a constant value. Because it's in all caps with underscores, that's a naming convention we use in Java for constants. I can also tell it's static because I'm accessing it with the name of a class. Class names, by convention, always start with a capital letter. Attribute names and method names, by convention, always start with a lowercase letter. You can do it any way you want. The language doesn't care. But again, it makes it easier to read your code if you follow the convention. So I know that highGoal is a constant value that is a static that's in the class parameters. And I'm passing that constant value to the shootGoal method member of GameMech. I know it's a method because A, it starts with a parenthesis immediately following it, and B, it starts with a lowercase letter. You can also use it with the scope of. So we mentioned the import statement when we first looked at the structure of a Java class. Every single reference, external reference you make use of has to be imported. So here's an import statement. I'm importing the CanJaguar class in the scope of WPI libj, which is in the scope of WPI, which is in the scope of edu. So what's the order of operations? Java has a very precise order of operations. The first thing that it evaluates are postfix operators, plus plus and minus minus. Remember I said with pre-increment and post-increment, there are slightly different ways the expressions are evaluated. This is part of it, the order of operations. After our postfix operators, then come the rest of our unary operators. That's the prefix increment, prefix decrement, the unary positive and the unary negative, and the not. Next comes multiplication. Multiplication, division, and modulus. These are evaluated left to right as they're written after we evaluate our postfix and prefix and unary operators. Next comes addition, additive. Additive, which is both addition and subtraction, are evaluated after multiplication. Next comes the relational comparison operators. Less than, greater than, less than or equal to, greater than or equal to, or instance of. Instance of is one of those special ones. It's outside the scope of this introduction to Java, but just know that it's there. Next comes equality. That's the equals and not equals. Next comes the logical and, then the logical or, then the ternary operator, which is another one. It's outside the scope of this Java Introduction to Java course, but it is there. Lastly comes assignment, and that's really handy when we start chaining operations together. We can also explicitly control the order of operations with parentheses. Just like in algebra, I'll give you two mathematical examples with parentheses. The first one, 2 plus 6 divided by 3 plus 1. In this example, we evaluate the division first. 6 divided by 3 is 2, so that evaluates to 2. So we then evaluate 2 plus 2 plus 1, which is 5. If we put parentheses around it, 2 plus 6 divided by 3 plus 1, we're now forcing Java's compiler to evaluate the expression 2 plus 6 first, which is 8, divided by 3 plus 1, which is 4. So 8 divided by 4 is 2. So it's the same mathematical formula. We're just changing the order of operations to get a completely different answer. So we can apply that to more complex examples. If we look at this example, we start at the innermost nested parenthesis, y divided by x. We evaluate that expression, which is probably going to be a double, and then we pass that as a parameter to the arctangent member of the math class. This is a static method that's in the scope of the math class, and I know that because A, I rendered it in italics, but also because we access it with the name of a class followed by the member of operator dot. The result of that arctangent operation is then multiplied by 180. Then the results of that are divided by pi. Pi is a constant value because it's in all caps, and it's also a static value because it's accessed with the name of a class. So it's the pi member of the math class. Lastly, the assignment operator is the lowest order of precedence. So the assignment operator is evaluated last. It takes the result of this entire thing, evaluating this entire expression, and stores it in the local variable alpha. Remember, whenever, this is a coding convention that we we should follow. Whenever we access a static, either a method or an attribute, we always specify the class it lives in and a dot operator to be explicit that tells the reader this is a static. So I touched on using comparison operators with object references. The equals and the not equals will always look at the location in memory where an object is located in the heap. So here's an example. A little code snippet. I have a value class. I'm creating a reference to value called value A. I'm assigning it a new value. So operator new will create a new instance of value on the heap and return the address. And it's going to use the constructor that takes a string parameter. And I'm passing it cat. So I know that value A is referring to a value object whose state contains cat. I'm now creating a different value reference, value B. I'm creating a different object on the heap, and I'm initializing it with the exact same value, cat, and I'm storing its address in value B. Now when I use the comparison operator, if value A is equal to value B, am I going to print out same or am I going to print out different? In this case, I'm going to print out different because the address in memory where these objects live is a different address. These are actually two different objects. So what if we actually wanted to compare the value that the objects contain? Every class in Java has a method equals, which you can override. And the declaration of the method equals is it will compare the contents of the objects that are passed in. Remember all the way back to the beginning when I introduced object-oriented programming, I said a class is a specification. A class is a contract. Every class in Java inherits from the class object, and the class object contains an equals method which has a declaration that you have to abide by. That's part of the inheritance contract. So the equals method will always compare the internal state of an object. So if I wanted to actually compare that value A and value B had the same state, I would do it this way. First, I have to make sure value A is not equal to null. If I try to invoke any method on a null reference, I'll get a null pointer exception. So if this expression evaluates to true, and the logical AND evaluates left to right, and the right-hand value evaluates to true, I'm going to perform what's inside the curly braces. And for here, I'm going to invoke the equals member of value A, and I'm passing it value B. So that's how equals will be able to compare the contents of value A and value B. So I've already gone over this, but I'm going to touch on it again. The Java methods perform behavior on an object, and we invoke a Java method with the dot operator, which is the member of operator. We have to use parentheses even if there's no parameters passed to the method. Otherwise, Java is going to assume your declaration is a variable, not a method. So this example, we're invoking the set method member of disengaged solenoid. I know it's a method because it is immediately followed by an open parentheses. This following method invokes the robot init member of stronghold robot, and it takes no parameters. Even when it takes no parameters, it still has to have an open and closed parentheses. So it's important to point out when you're invoking a method in Java and you're passing parameters, every one of the parameters that you pass to a method is an expression, which means you can chain together operators when you're evaluating your expression. So for example, here I'm invoking the setX member of left motor, but I'm passing it an expression. I'm passing it the set point multiplied by -1. And then immediately following, I'm invoking the setX member of right motor and passing it set point. So you can see I'm reversing the value of set point for the left side and the right side of the robot. When we get into the next class, I'll show you some more elegant ways to do that, but this way works. So I just wanted to point out, every time you pass a parameter, you can supplement that parameter as an expression. Java methods that return a value can also be used as part of an expression. So in this case, getRawButton is a method that returns a value. The Java coding convention is that whenever we have a Java getter that returns an attribute from within a class, we name it starting with the word get. So I know getRawButton is getting a value from inside the class. So that means it's returning something. If it returns a Boolean, we name it starting with the word is. So I'm going to invoke the getRawButton member of GameStick, passing it the parameter shoot, which is a constant static in the scope of parameters. And then I'm evaluating if getRawButton evaluates to true. If it is true, I'm going to then invoke the one Java statement inside a Java block, shoot member of GameMech. So basically, if the shoot joystick button is pressed, the GameMech is going to shoot. Here's another example in a Java declaration. I'm invoking the isLowGear method member of drive, and that is evaluated first. Then the assignment operator is evaluated last. The assignment operator has the lowest order of precedence of all the operators. Whatever this returns is going to be stored in the LowGear Boolean local variable. So that's it for this module. Hopefully you're starting to see how everything that I went over in the earlier modules is starting to piece together to actually create Java program logic. Next module, we're going to go into the control of the expressions using loops and more complex conditional statements. So be sure to tune in for the next module. Thanks for watching.